In today's video, we're going to walk through one of the easiest ways to visualize the progression of an athlete's testing data using Rstudio and the ggplot package. We're going to walk through the specific code that I use to plot the jump height of the athletes that I'm working with. And then the process and the systems that I show you today can then be applied to any type of testing data that you're working with, from 1-rep max testing to isometric strength testing to sprint timing. The visualization method and code that we're going to be walking through today has set the foundation for all of the reports that I've been running since 2018 when I started working at an Olympic training center. It's an easy workflow of drop in your master file, pick the athlete, and get a clean figure every time. First, we're going to load the data into Rstudio. Then we're going to create a basic visualization that we can work with. We'll level it up in the third step with some better aesthetics so it actually looks professional. And then we're going to save it with the athlete's name and the date that the figure was created in the file name so you know exactly who it belongs to and when it was made. So let's get into it. First, we're going to load in all the packages that we're going to use. And to save time and myself from typing, I just have these saved somewhere and I copy and paste them into the start of every script that I write. So there it is there. This is what we're going to be using today. From there, we're going to load in the file. And in this case, I'm just going to call it the jump file, and we're going to use the read XL function. And in this case, we're going to go back into the Finder of our computer, find the file, and copy and paste the path name so that we don't have to type it all out, and that'll tell us where the file is on our computer. So now that we've got our file found on our computer, we're going to load in our packages by pressing Command and Return with them all highlighted. And then we're going to do the same thing on the line of code with jump file. And now we've got our jump file in there. We can double click it here and we can see what the data looks like. So you can see we have 93 total jumps that we're looking at, a number of different athletes, and a bunch of data. And one of the things that we want to do is we want to figure out what athletes are in this data set. So we're going to see the athletes and use the unique function to look at that with jump file and athlete. And that'll give us our list over here that we can look at for which athletes we want to use. And in this case, let's say we want to use Stevens B. So because we know who it is, we're just going to put report.athlete equals Stevens B. So now we know that this is the athlete that we're going to be working with. From there, we're going to filter the data so that only includes the relevant information or the relevant jumps from Stevens. So we're going to go filtered jump file. So in this case, we're going to create a new data set called the filtered jump file, and we're going to filter the original jump file so that it only includes the athlete column that has the report athlete in it. And you can see it now we're down to 21 results. From here, we can go in and start creating our basic visualization for this athlete. So we're going to call this the jump height plot using ggplot. Our data is going to be the filtered jump file, and we'll set some aesthetics here. We always make the date a factor because it allows you to sequentially put the dates along the y or the x-axis. Otherwise, it just gets all messy and it doesn't look great and it is out of order. So we make it a factor. And for this, we want our main line to be the jump height max. And we're going to group them by athlete so we can connect the lines of our scatter plot. So at this point, what we have here is So at this point, what we have here is the basic code to plot just the max jump height for this athlete. However, when I look at jump height, I want to see the max and what the average is from that given day to see how those line up in the spacing between them. So we're going to add in another set of parameters so we can have the average jump height also included. And that's where we set the jump height mean here. And this is going to be the code for our basic visualization. So I'm going to press Command and Enter on that. And what I'm going to do is I'm just going to copy jump height plot and I'm going to put it down here into the console. And we'll press Enter on that. Oh, and I forgot the J. There we go. And it's going to look like this. So looking at this figure, it's not really the most beautiful thing that we've ever seen. However, we have the basic components that we need. We have jump height, max, and average on the y-axis, although this title doesn't really reflect the mean being there. So the mean is in the gray, and the black is the max height for the given session. You can see we have the dates along the x-axis. They do get a little bit compressed, which doesn't look great, so I'd like to change that. I don't really like the gray background. I think it washes things out. And what you can see is the y-axis is pretty spread out, so it fits the data. However, it makes some changes here look huge. So this looks like a very big drop off between max height and average height on March 25th. But really we're looking at 44 and a bit to just shy of 42, so it's a 2 centimeter gap. But a coach seeing that might think that is a huge red flag. So I like to change the axis limits so that it kind of compresses things and keeps coaches a little bit more under control. What we also see here is there's no units. The title down here is factor date in brackets, like nobody wants to see that in their figure. So we need to clean some things up and probably put a legend as well so that you know that the black line is the max and the gray line is the average. So that's what we're going to do in our next one. So to create our figure with a better visualization or a better aesthetic, what I'm going to do is I'm going to copy this first line and I'm going to put it in here in the better aesthetic commented area, and I'm just going to put this as jump height plot number 2 so we know that it's different. And then from here we're going to start building, and I'm just going to put a bunch of lines down here so that things are more centered because I don't like working at the bottom. So a lot of this is going to look the same. There are just some subtle details that we're going to change here. So we're going to set the aesthetic for our first geometric line and set that to max height. And what we're realizing here is I'm struggling at typing. I usually type on my computer, but I have this little keyboard so that I can have my computer raised up higher just for filming setup. And I hate this little Apple keypad and I suck at typing on it. So apologies for that. So that sets our geometric line so that it's labeled as max height, which is going to come in handy later. We're going to do the same thing for geometric point. And what you can see here is I'm also changing the size of the points and the line. So the line is 0.5 and the point is size 2, just because I don't love a real thick line connecting the points. So I make it about a quarter of the size of the point. And then we're going to do the same thing for coding in our average jump height. So we're going to do geometric line, AES y equals jump height mean color is equal to average height. Size is 0.5. And then same thing to create the point for here. And at this point, I'm just going to copy and paste this because I'm getting a little lazy. That's the one thing about code is actually a lot of repetition. And you can work to get rid of that repetition so it's not as clunky. In this case, there's not a whole lot you can do. So there's a lot of copying and pasting going on here. And then we're going to set the scale color manual. So this means we're going to set the colors associated with our points and our lines. And we're going to do that manually, hence scale color manual. And just like our last one, we're going to set the max height to equal black, if I can spell it correctly. And we're going to do the average height as gray. So that's going to set our lines, our points, and our colors. Next, we're going to go into adding some labels around the figure. So we're going to go X label, X lab is date, Y lab is jump height in centimeters. And then we're going to go title equals CMJ height. And we're setting color equals nothing. Next is setting the Y scale. So we're going to go Y scale, or scale Y continuous, and we're going to set our limits equal to 0 and 60, because generally I don't see athletes jump more than 60 centimeters. So I find that having it from 0 to 60 gives me a really good visual immediately when I look at the figure of how they compare to other people in the sport. In which case, if they're close to 60, they're probably doing pretty well. And it's just like a very, very fast, like quick look, see what's going on. And then we're going to do the breaks. So we're going to go pretty breaks. And we're going to set that to n equals 12. So that means from 0 to 60, there's going to be 12 horizontal lines to create a grid on our figure. Then we're going to set our overall theme. And I do use the black and white theme with a base size of 12. And from there, we're going to mess around with some of the formatting of the text on the X and Y axis so it's bold and aligned the way that I like it to be. So we're going to use the theme function, and the first thing that we're going to do is we're going to change the dates so that they're rotated 90 degrees so that they're easier to see, especially once you get a whole lot of data. Things can get squished like you see down here, but if they're rotated 90 degrees, then they never run into each other. I like the look of that. I think it works well and it looks well. It looks good. I also make the text just a little bit smaller at 10. And I make it bold. And then for the y-axis, we're going to do the same thing. Color is going to be black. Face is bold. And we're going to leave that at the angle that it's currently at. We don't have to rotate that. So that is the numbers that we'll see on the y-axis. Now we'll do the titles for each one. So for the x-axis, we're going to do the same thing, and we're just going to copy this because I'm getting a little bit lazy. And let's save some work for ourselves. And we're going to do the same thing here for the y-axis. The only thing that we're going to change is we're going to put the angle to 90 so that it runs vertically like this, as we see in the first plot. From there, I'm going to press Command and Enter, and then we're going to bring the jump height plot 2 down into our console, and we're going to press Enter there, and we can see what the new. So now we have a much better looking plot. If we look along the x-axis, we have our dates in order from left to right, oldest to newest, with the labels rotated 90 degrees. I like the look of that personally. You can also have it at 45 degrees or just leave it horizontal. I think it runs into each other and looks a little messy. We have date as our title on the x-axis. The y-axis goes from 0 to 60 with jump height in centimeters listed as the title on the y-axis. Our overall title for the plot is CMJ height, counter movement jump height. It could be written out fully if you wanted to for your coach or for your staff. And then we have our legend on the right, indicating which is the max height and the average height. And again, like I mentioned before, having things spaced out on the y-axis with a fixed start and end point, I think really gives better context of what's going on with the person's jumps, rather than having having the limits be smaller or tighter and seeing huge jumps and variability. We can add a little bit more nuance to our interpretation with a spread out y-axis. And if you want to send this to somebody, obviously you have to save it. So let's get into how to save this plot. So now that we need to save it, we're going to use the ggSave function. We're going to tell it what plot we want to use. We want to use plot number 2 because that's our better one. We're going to set the file name. And that's one of the things that we're also going to use is we're going to use the paste function. And that's going to allow us to put the athlete's name in the file name and also today's date. So those are part of the file name and things don't get lost, and you don't have to go back and add those in later manually. So what you can do is you can just use the report athlete variable, and that will put the athlete's name at the start. So in this case, Stevens B. And then we're going to put CMJ height in brackets, and then we're going to put our system date. So that's going to put the day that we created this, and then we'll add in .pdf. So the file name, or the file path for me, is going to be that. And then we're going to set the height or the size of the figure. So in this case, I'm going to go a 10 by 8 with a DPI of 300. And we're going to press Command and Enter, and that worked. So now we've navigated to my desktop to find this, jump height figures. We're going to have Stevens jump here. So it's last name, CMJ height, and the date, which is the way that I like my files to be named. And from there, we can open it up, and this is what it looks like. So then we can send that off to any of our coaches or anything like that. So I hope you found that valuable. I think it's a really easy workflow that you can apply to any of your teams or any of your testing data. Up next in the series will be how to automatically create figures for a list of athletes or a whole team all in one click. So be sure to check that one out too. Thanks.